All right, so since you guys are going to be finishing up your homework for section 3.4 this week, I wanted to go through and just touch on a couple of things, a couple of problems in section 3.4 that might need a little bit of clarification for you. This is one that I had a specific question about. The information that you're given here, instead of being given frequencies, which is what we're used to, like a number of people, we are given percentages in a pie chart. And so the main thing about this is to convert everything to a frequency first. That way you can determine your N and your R that you're looking for in the particular problem. All right, so what I would do in a case like this is I would start out and I would look at, instead of percentages, I would look at a frequency for each category. So notice right over here, we are told that we're looking at 1,400 total people. All right, so if I have 1,400 total people that I'm looking at, and I'm given the percentages for each group, right? Notice, for example, if I wanted to know how many people would rate their financial shape as excellent, I can take 8%, right? That's the percentage that's given, and apply that to this group of 1,400 total people. All right, if I do that, then that's going to show me that there are 112 people in this group. All right, and if I needed, I could do this for each one, right? So I could take 42%. If I needed to know the number of people who rate their financial shape as good, and that would tell me that there are 588 in that group, and so on. And if I do that, the frequencies that I get, they will sum back to this total of 1,400 because that's the total number of people that we're basing this on. All right, so now once I do that, then if I want to come down here and start calculating probabilities, the first thing that I would do is I would calculate my total number of outcomes, right? So we talked about, look at the big picture first. Understand what counting rules should be used, and apply that to get your total. So for right now, I'm not going to look at anything for the probability, right? Nothing specific. I'm just going to look at the fact that I want to choose 4 people, right? That's my R, how many are being selected. And I want to choose those from a group of 1,400 total. All right, now obviously this is going to be a really big number, so I'm not going to evaluate it. Right, but I'm going to write down here that this would be 1,400. I'm using combination in CR because the order does not matter here. We're not arranging, we're just selecting 4 people from a group. All right, now, I understand the total, right? I understand what counting rule is used. So now I'm going to come back over here and look at the probability that all 4 would rate as excellent. So all 4 people selected would rate as excellent. All right, now that we've converted everything to frequencies, this is going to be very similar to the problem that we did in class where we were filling offices and we were basing it on people who were not on the debate team. So all I'm going to do here is I'm going to note if I want only people from the excellent group, then that means I can only choose from the 112 people who said their financial shape was excellent, right? So probability here is event over total, right? We did our total already, 1,400 NCR4. Now remember, when you don't have a simple event, right, and this one's way too general to be a simple event, you use the exact same counting rule. So we already know this is an NCR. And then we note we're only choosing from the excellent group for this event, right? So we're only choosing from the 112 people in that group. We are still talking about selecting 4 from that group. And so now I've counted my event and I'm dividing by my total. Now remember, these are going to be really big numbers, so you don't have to evaluate each one individually. You can type it in your calculator just like this, 112 NCR4 divided by 1,400 NCR4. All right, this is a small value here because we're talking about a small group here, so I'm getting 3.8 8968, which obviously can't be a probability. It's not between 0 and 1. So I notice I've got this e minus 5. And again, like we talked about in class, this just means we need to move the decimal 5 places to the left. So I'm going to report my answer here, 0.0000, right, once I move that 5 places to the left. All right, now I'm asked to round my answer to 6 decimal places. So when I go to input my answer here, if I round this to 6 decimal places, obviously very small probability, 0.000039. All right, so let's come back over here and check it. And we have calculated that probability correctly. All right, so any group that I want to look at there, the main thing is I would just need to convert that percentage to a frequency, and then I'm going to be able to apply my combination rule and select my N and R accordingly. All right, now one other one that I just want to bring your attention to. I'm not going to work this one for you. I'm going to leave that for you to do. But I want you to notice on this particular problem, this is also similar to the one we did in class with, selecting people who were not on the debate team. However, I want you to notice that this one, when you go to find the probability, it's giving you a partial selection. So notice here, it tells you 8 workers are going to be chosen. So you know it's going to be an NCR 8. But then when it asks you about the probability, right, it only tells you about 5 workers. So this is actually going to be more like the problem that we did in class with the corn kernels, where you're going to use your NCR function to choose those 5 first shift workers, but then you're going to have to make another selection. You're going to have to multiply by another combination because there are going to be 3 remaining workers that have to be selected. All right, so just keep that in mind when you look at this particular problem. And if you need something to reference, go back and look at the problem that we did in class where we were looking at selecting the 4 corn kernels.